We are discussing physics problem number 48 today, which is also from the IIT 2025. You can see the statement on the board, and also the topics are ray optics and wave optics. Both branches of optics are involved. In subtopic wise, you can say reflection, refraction and polarization. These three concepts are involved. Now, let us see what is given. There's this solid glass sphere is mentioned, in which there is a cavity, air cavity is there, of half the radius. Sphere radius r, this radius is r by 2. And there is a small, generally if you make like that, there may be a small opening here, but that is covered with another glass, small glass piece, covers that. So a source is producing a light, monochromatic light, source S, that goes and reflects at the periphery of the sphere, glass, that is the glass portion. Reflection takes place. So that angle of incidence theta is what is required. This is the normal. Radius is the normal. So angle of incidence theta is required, and because angle of reflection will be equal to this will be theta also, this angle of reflection. And because this radius are the normals, so this radius, both radius are equal means this isosceles, so this angle will be theta also. Again, this is also theta by reflection rules. So this is theta also, this is also theta. This theta is what we want. So again, it will be theta here and theta here. That is, after this number of reflections, it is subsequently, it is reflected at this glass piece, where the reflected ray is totally polarized, fully polarized wave. Fully polarization means this angle must be, because when reflection occurs from a lighter medium to a dense medium, and if ray becomes totally polarized means that angle of reflection, this angle of incidence must be the Brewster's angle. So this must be Brewster's angle. This angle must be Brewster's angle, theta b. Theta b, Brewster's angle, is related to the ray incident at O must be at Brewster's angle. Brewster's angle. At B, at O, that is O is the glass piece. Brewster's angle at O, theta b. This theta b is related to refractive index, by where implies tan theta b must be equal to the mu of the medium. Mu means the refractive index. Here they are using another symbol n for the reflection. N equal to n. N is equal to root 3. Implies this theta b must be equal to 60 degrees. Theta b must be 60 degrees. For this theta b to be 60 degree, and that is, here it is 60 degrees. So this is radius, this also radius, means this is an isosceles triangle. So this full angle of, this is the normal here. With that normal, angle of refraction also must be 60 degrees. So for which, what is the angle of incidence I? This angle of incidence I we have to work out. So we apply at P, this point P, we apply this Snell's law. Snell's law at P implies at P implies this medium is air, so refractive index 1 times sine 60, 1 times sine 60 should be equal to root 3 times sine I. I is this angle, because this with this normal is making angle I as an angle of incidence, so root 3 times sine I. Sine I. This is also root 3 by 2. So, this is also root 3 by 2. So, this implies sine I is equal to half, or I is equal to 30 degrees. So, this must be 30 degree. And when you produce it back, again 2 30 degrees are formed inside. I will continue further after clearing the board. Now, after getting this theta B equal to 60 degree and I equal to 30 degree, and once you get the diagram clearly like this, the rest is calculation part is very simple only. Now, because you produce this AP backwards, producing AP backwards gives right angle triangle. Producing AP backwards, gives right angle triangle ABC, gives right angle triangle ABC. Once we get that, the rest is calculation is just straightforward. This is 30 degree. This is also 30 degree. This is also 30 degree, because you're producing it back like this. So that what we want is sine theta. Theta is marked here. So this right angle triangle ABC we are getting. This is right angle, in which this length is r by 2, radius from here to this r by 2. This, because this is 30 degree and this is r by 2, this must be r by 4. So that just gives us the answer immediately. AC is equal to r. AC is equal to the original r. AC equal to r. The opposite side here is CB. CB equal to r by 2 plus r by 4, giving us 3r by 4. So we get sine theta. Now this theta required, sine theta is equal to opposite side being 3r by 4, hypotenuse is r, so giving us 3 by 4 as the required answer. Since or sine theta is equal to 0.75, because 2 decimal places you have to give the, you have to mark the answer in the test paper. So on the answer sheet you have to mark in 2 decimal places. So answer to the question now turns out to be 0.75. 0.75. So once you get this diagram correctly, the rest is simple. So many reflections are involved before final refraction and again reflection. and we are making use of the Brewster's angle concept. So that is why I said the three optical concepts are involved: reflection, refraction, and polarization. So if you understood the concept and the method and the diagram, okay, thank you. Thank you for listening.